Alright, this is Schweitzer moving along here. What happens when I mix acids and bases as part of our school of acid and base? And this is pretty common question that we would move to next. What happens when I mix them? We know what causes something to be acidic. We know what causes something to be basic. We know how to calculate the individual concentrations and pHs of all these things, or we should. What happens when I mix them? We call this a neutralization reaction. So let's try some examples. Okay, so let's say I have HCl plus NaOH. Just to write out the equation, and I'll do that first, we have cation, anion, cation, anion. So if I write this out, it would be HOH, which is sometimes just written as H2O, and that took care of those two. And then cation, anion, I get NaCl, and just, you know, that's quite aqueous solution, dissolves well. This is liquid. Alright, and there you go. In this case, if I were to draw a picture of these guys, HCl before picture, NaOH before picture, and then the after picture. Okay. And HCl, being a strong acid, would just be H plus Cl minus. NaOH being a very soluble base, Na plus OH negative. The H in OH now, in this case, would produce just water, H2O, and then NaCl would still be floating around by themselves because that's how they are. They're very soluble. When ionic compounds dissolve, they stay apart. So this is called the molecular version. Okay. In this situation, what do we get out of this? Well, we have two other versions we can write. One's called the ionic version, which we just draw things kind of as they are in the beakers. H plus Cl minus plus Na plus OH negative yields H2O, because it actually forms liquid, plus Na plus Cl minus. Then we have the net ionic. Alright. This, in case we just scratch out the spectators. The chlorides and the sodiums, they aren't doing anything in this process. Really, we have H and OH coming together to react. So it's from H plus OH negative yields H2O. And in my opinion, this is really what happens every time you mix an acid and a base together. All right, and I've drawn some pictures of them. A different version of this might be what happens if we mix, let's say, a weak acid and a base. So let's take, for example, HF. Let's do HF plus NaOH yields. Now, in this past option here, I called them, okay, well, they're both strong acids, but you should be keenly aware, strong base, that really, whether you're strong or weak doesn't make a difference. It really would be down to the concentration of your hydroxides and H pluses. How many do you have? Not whether you're strong or weak. Alright, so in this situation, I happen to have a weak acid and a strong base. As I draw this picture out here, I have HF. Now again, HFs, they don't go to products much, so we would generally write it out as HF, HF, like that. Draw two of them. The NaOH would be listed as just a, okay, Na plus OH negative, Na plus OH negative. They're split apart. So let's just draw our products. Cation and the anion is NaF, which happens to be quite soluble in water, and HOH, which is your water. Let's draw our beaker out here. Okay, now in this case, get Na plus, spectator, Na plus. Okay, now in this case I get H and OH forms water, and H and OH forms water, and then we get the fluorides. The fluorides are just floating around. Now, just by convention, the way we show it for an AP test or whatever, and my tests, a spectator is something that does not change at all. So you'll note that the HFs were connected previously, even though it's a small amount. Is actually produces is going through hydrolysis in this reaction here. So this is technically a two-step reaction where this guy would go through hydrolysis. HF plus H2O yields H3O plus F negative, and then the H2O plus would react with the hydroxide to produce water, which is the same reaction we have here. But this is how we generally show it. HF, keep it together, plus Na plus OH negative yields H2O plus F negative plus Na plus. That's what it looks like. This is our ionic form. And our net ionic form, because technically that a change occurred here, I'm going to leave it as HF plus, now Na is our spectator, OH negative yields H2O plus F negative. And that is the net ionic for that guy. This is together because it's a weak acid, and the picture showed it together. Okay. So, a couple things we have top here. Let's see if I miss anything. Can I write out a neutralization reaction? The typical neutralization reaction is an acid plus a base yields salt and water. And here's my salt, and that's a cation anion, right? So here's my salt. It's a pretty general form. Don't always think of it like that, but that's a general form. Can a strong acid neutralize more than a weak acid? Strength has nothing to do with it. It really has to do with the overall quantities of H's that you have and the quantities of hydroxide you have. And whether you're strong or weak, our base will eventually get it. Right? It's just might take a tad bit longer, or that's about it. So, what happens when acids and bases are mixed?